Hi guys, I hope you're doing well. In this video series, I will be explaining to you what do you understand by VPC, how would you go around creating subnets, internet gateway, NAT gateway, and once everything is explained in the coming video, I will be explaining how would you configure this using CloudFormation templates. So stick around and I'll see you in just a moment. So when you want to configure your first VPC, you need to take care of one thing. And the first thing is to create a CIDR block. So what a CIDR block does is, it manages and tells how many IPs you can assign to all the components that are provisioned inside your AWS. Let us say you have 5 EC2 instances. All those 5 EC2 instances need to have a separate IP, right? And the number of IPs that you can have in your VPC totally depends on the CIDR block that is assigned to your VPC. So here in this example, I have 10.0.0.0/16. So this is what that tells me, that how many IPs I can have which I can assign to all my resources. So here what this 16 is, let me tell you a small, very easy shortcut that would always help you remember what this concept is all about. So /16, whatever is after the slash, just divide it by 8. What is 16 divided by 8? That is 2, right? What that means is the first 2 bits of this IP address are reserved for your VPC. Wait, what does that mean? That means whichever resource is allocated with whichever IP, the first 2 bits will always be the same. And the rest of the bits will be divided to your resources. So for example, this EC2 instance right here can have an IP of 1, 2, 3, 4, 5, 6, whatever you want to call. And the first 2 bits will always be the same. The same thing is happening here. The first 2 bits are the same and the rest are being changed. This is because of something called CIDR block, and which is defined by whatever is written right next to the slash. So whenever you deploy a web application, most of the web applications have an architecture wherein there is a separate front-end code and a separate back-end code. The front-end code is responsible for what the user sees or receives on the web browser whenever he or she requests for a web page. So in order to deploy your front-end part, the front-end code, similar, you could say React, Angular, Vue.js, all those front-end libraries code, you would need to have a separate little tiny area in your infrastructure that would be open, that would be public to the internet. And that is something called a public subnet. Similar to this public, you would want a private section in your VPC which would contain all the backend related code which the user never sees. And the idea behind keeping all those code related to databases, related to REST APIs and all that kind of good stuff to be in the private subnet is to keep it secure and to keep it isolated from the outside world. Because you wouldn't in any case want your private subnet resources to be exposed to the outside world in any way possible. Now you must be wondering, what is this thing right here and this thing right here? So in order to divide your VPC in 2 separate subnets, you need to further put a constraint on how many bits are reserved for the network. So here I have written /24. So do you remember my shortcut that I told you? 24 divided by 8 is 3. What does that mean? The first 3 bits will be reserved for the network and only the last bit can be changed. So it could be 1, 2, 3, 4, 5 and all that up to 255. So let us say I have an EC2 instance in my public subnet which has React code running, the front-end code for the web application. It could have an IP of 1, 2, 3, 4, 5, 6, 7 till 255. And similarly, just to differentiate public subnet and private subnet, I have changed 1. I've put 1 here instead of 0. So what does that mean? The first, even here it says 24, right? So the first 3 bits are reserved for the private subnet and only the last bit can be changed. That is the reason why you see the IP right here to be like this. Now, whenever you create a VPC, it always comes with something called a route table. A route table is something responsible for routing the traffic inside your VPC. So the CIDR block of my VPC is this. So the route table would have an entry exactly like this. What it means is whatever the traffic comes from wherever inside this VPC, from this VPC, should be routed locally. What does that mean? That if this EC2 server wants to communicate to this EC2 server, it would have the traffic would go there, then it would go here. But since we have divided our VPC in two subnets, we need to have route tables for those respective subnets. So since these subnets are part of this VPC, they would obviously have the same entry replicated in their respective route tables. Why? Because let us say this instance wants to communicate to this instance being a part of the public subnet would reach out to its own route table, which would forward the request to this EC2 instance. Now, as I told you, the main purpose of keeping resources in the public subnets is to be able for them to communicate to the outside world, right? Suppose the website is hosted here and a user types www.google.com, he or she would want the HTML, the CSS, and all those good resources to be received onto his web browser. But that cannot be done without the internet gateway. What internet gateway is, it acts like a bridge between your VPC and the outside internet. Right now, I do not have any internet gateway installed. So my VPC is totally isolated from the outside world. So the first step would be to create an internet gateway. Once the internet gateway is created in my AWS account, I need to associate it to my custom VPC. It is in detached mode right now. And once I associate it, it will act like a bridge between the internet and my own custom VPC. Now, the reason why we installed the internet gateway was for the users to communicate or send requests from their web browsers directly to our public servers, right? How would internet gateway know where all the public resources are present? For that, we put an entry in the public subnets route table saying all the requests for the outside world 0.0.0.0/0 need to be communicated via internet gateway. So what does that mean? If the request comes to this VPC, it will first go to the internet gateway. It will forward it to the route table because internet gateway's entry is right here. It will send that request to the EC2 public server. That will send the request back to the internet. That will be routed to the internet gateway, and that way the user who requested for the web page will receive the web page on his web browser. So this was the case when the internet needed to be coupled with the public subnet. Now let us say this EC2 instance in the private subnet needs to communicate to the outside world. Your first question would be, if that EC2 instance wanted to communicate to the outside world, what the hell is it doing in the private subnet? That's a good question. Now, to answer that question, let me explain you what a NAT gateway does. So the NAT gateway is sort of like a representative of all the resources that are there in the private subnet. It has a public IP. That is the reason why we keep the NAT server in a public subnet. So what it does is, suppose this EC2 instance, which is there in the private subnet, needs to access, let's say, a database that is running on Google Cloud, which is outside this VPC, which means it needs to communicate to the internet. It would do that via NAT gateway. Now, your question would be, why didn't we use the same entry that was here? Why didn't we use internet gateway for this? Because NAT gateway allows all the traffic to be routed via NAT gateway to the private resources, which acts as an additional layer of security between the internet gateway and the private subnet. So let me give an example real quick that will make this concept very clear. Let us say this EC2 instance needs to communicate to this database. For that, the request would go to private subnets route table, where I have written, okay, so whatever the traffic is for the outside world, that is 0000/0, should be routed to what? NAT gateway. So the NAT gateway here, which is present in the public subnet, will see, okay, the request is for the outside world, that is 0000/0. So the NAT gateway would go to its respective route table, and that is the public subnets route table, and will send the request to 0000/0, which will send the request to internet gateway, which would send the request to the outside world, that is the database. So by doing this, you added a layer of security, and if a request returns from this database, it will go to the internet gateway, and the internet gateway will send the request to this public elastic IP, which is associated with the NAT gateway, which will in turn send that request back to the private EC2 instance. So by doing this, you did not have to expose any of your private resources, and this NAT, as a representative of your private resources, handled all the requests and acted like a bridge between an internet gateway and the private subnet. So I hope all this made sense to you, and if it didn't, just write down your queries in the comment section down below, and I will get back to you for sure and explain to you whatever your queries are. And in the next video, I will be showing you how you could provision all this infrastructure using a CloudFormation template with a single click of a button. So I'll see you guys in the next video.